Welcome to the Explainer. So, for well over a century, the arrangement of letters literally right at our fingertips has sparked rumors, intense academic debates, and honestly, just a whole lot of misunderstanding. Today, we're going to unpack this bizarre history together. We'll act as forensic historians, digging into the data, the probabilities, and the mechanical ghosts of the past to finally uncover the true origins of your keyboard. Okay, let's dive right in. Take a second and actually look down at your keyboard right now. Why are the letters scrambled in such a seemingly chaotic way? I mean, Q, W, E, R, T, Y. It's not alphabetical, it's not grouped by vowels. If you've ever watched a kid trying to hunt and pack for the first time, you quickly realize just how totally counterintuitive this layout really is. To understand why we're all locked into this specific arrangement, we have to rewind all the way back to the 1870s. To solve this giant puzzle, we need to look at this giant circular 1873 type basket. It was designed by Christopher Latham Scholes, and this single piece of mechanical hardware is basically dictating our modern digital lives 150 years later. You see, the letters on the early keyboards were directly linked to metal bars. They called them type bars, and they were arranged in this circular basket underneath. When you pressed a key, a metal bar swung up to strike the paper. And that mechanical action, that's the root of everything. Section 1. Myth number 1. The salesman's trick. Now, there is a super famous rumor out there that the top row was specifically designed to help typewriter salesmen easily peck out the brand name to impress customers. And, well, it's actually true that the word typewriter can be typed using just that single top row of keys without ever hunting around the board. Try it. Typewriter. It's all right there. But was this an intentional design choice or just a really weird coincidence? Well, an academic study from the University of Strathclyde actually ran a statistical probability model on this. They calculated that the chance of those exact 7 letters landing on the same row completely randomly is just 1 in 5,000. That's a 0.0002 probability. So no way. That's more than enough to completely reject the idea that this happened by accident. This brilliantly illustrates a point made by economic historian Paul A. David. This wasn't a fluke. Grouping those letters together was highly probable to be a deliberate, calculated sales tactic. You have to remember, a Remington typewriter in the 1870s cost a whopping $125. That was an astronomical amount of money back then. Salesmen absolutely needed a slick, fast trick to demonstrate this strange new technology to skeptical buyers. Moving on to Section 2. Myth number 2. The anti-jamming theory. So what about the rest of the keys? Were they designed to deliberately slow down typists to prevent the machine from jamming? That's the standard myth, right? It says Scholes got a list of the most frequent English 2-letter pairs and separated them on the keyboard. This was supposedly to stop type bar jamming, because if 2 bars sitting right next to each other in that circular basket were struck super fast, they clash, jam, and stick together, completely ruining your workflow. But here is the massive hole in that theory. Let's look at common pairs like ER, which is easily one of the most frequently used letter combinations in the entire English language. The QWERTY layout actually places the E and R keys literally right next to each other. If Scholes was purely trying to separate common pairs on the keyboard itself, he did a pretty terrible job with one of the most common pairings of all. Plus, using a really clever round-table seating analogy, those same University of Strathclyde researchers found there's a 52% chance that the top 12 frequent letter pairings would just naturally separate themselves on a 44-bar type basket if they were placed completely at random. So Scholes didn't even need to engineer a complex layout to split up frequent letter pairs. The math would have just naturally done it for him over half the time anyway. Section 3. True engineering brilliance. So, if Scholes wasn't just blindly separating common letters to slow you down, what's the actual genius behind QWERTY? Well, he didn't focus on separating frequent English pairs on the keys. He ensured that keys situated immediately next to each other inside the physical guts of the machine, the contiguous type bars, formed incredibly rare English pairings. Think about the letters that physically touch in the basket, like Z and C or X and F. How often are you typing ZC or XF? Basically never. Let's say we just went with a straightforward ABCDEF alphabetical layout instead, mapping it to the alternating zigzag pattern of that type basket. Well, certain adjacent type bars like L and U would clash all the time. The physical mechanics would have been an absolute nightmare because LU is a relatively common letter combo. To really put this into perspective, researchers actually analyzed Mark Twain's Life on the Mississippi, which is famous for being the first manuscript ever submitted as a typed document. When Twain's typist wrote that entire 145,000-word book, they only hit contiguous QWERT type bars 146 times. If they'd been forced to use an ABCDEF layout, that number would have skyrocketed to 5,599 potential jams. I mean, that is the secret magic of QWERTY right there. So QWE wasn't some evil plot to slow people down. It was actually a near-optimal solution to a very temporary mechanical problem. Scholes separated vowels so they rarely touched other letters in the basket, and he cleverly used numbers and punctuation keys as physical buffers to prevent hardware collisions. It was a brilliant, highly effective engineering fix for its time.
Section 4. Beyond QWERTY, Global Variants.
Now, obviously, the English language doesn't rule the world, which led to some really cool localized adaptations that follow the exact same mechanical logic, just for different languages. For instance, in Germany and a lot of Central Europe, the Y and Z keys are swapped, creating the widespread QWRZ layout. If you look at a German keyboard today, QWRZ is absolutely everywhere. And the reason for this swap is super practical. The letter Z is way more common in German than Y, which they mostly just use in loanwords. And since T and Z frequently appear together in German, like in the super common prefix zu, they were placed so typists could strike them rapidly with alternating hands. It reduced jamming while actually speeding up typing for that specific language. Section 5. Echoes of the typewriter. All right, even though those physical clunky metal bars are long gone, we are quite literally still haunted by their mechanical ghosts in our modern software. You use them every single day, probably without even realizing it. Let's look at the timeline from the 1868 invention to the release of the Remington No. 2 in 1880. This specific machine introduced a feature you've definitely used today, the Shift key.
Think about it. It wasn't just some cute, arbitrary name. It was literally called Shift because pressing it physically lifted or shifted the entire heavy carriage mechanism upwards. This allowed the capital letters, which were sitting right there on the exact same metal bar as the lowercase ones, to strike the ink ribbon. We still call it Shift today, even though obviously we aren't lifting any metal carriages inside our laptops.
And it gets even crazier. If you look under the hood of modern computer programming, the code still uses CR and LF as hidden characters to format text whenever you hit the Enter key. That literally stands for carriage return and line feed. Those were the actual physical actions of pushing the typewriter carriage back to the left and rolling the paper cylinder up by one line. Our massive multi-billion-dollar software industry essentially still thinks it's moving physical paper around.
Oh, and your backspace key? You use it to delete mistakes, right? Well, originally, it was designed to just move the mechanical carriage back one single notch so you could type over a letter to create a brand new symbol. Like you type an apostrophe, hit backspace, and then type a period right over it to make an exclamation point. It was completely the opposite of the destructive delete function we use it for today. Which brings us to a really fascinating final thought to wrap up this explainer. If the very way we interact with the entire digital world is dictated by the physical-mechanical flaws of the 1870s, what other everyday objects are secretly ruled by the ghosts of the past? It kind of makes you look at the world a bit differently, doesn't it? Think about that the next time you send a text or hammer out an email. Thanks so much for joining me, and keep questioning the design around you.